All right, so for today, I'd like you to look over the segment on polyatomic ions. So in this section, these are the same polyatomic ions that are on the back of your periodic table. You need to memorize the name, the symbol, and the charge for these key polyatomic ions. Now there's literally tens of thousands there's thousands of these. So there's thousands of the polyatomic ions that we have here, but these key will be the common ones that will get us through most of the naming for ionic compounds. So these polyatomic ions, most of them are going to be negative ions. However, you should be aware there is one common polyatomic ion that shows up, which has a positive 1 charge, the ammonium ion. Now that's not ammonia, it's ammonium. So the first step will be knowing these set of polyatomic ions. And the reason why you need to know those is because there's going to be rules for naming the ions that are related to these. Now, the rules we're going to talk about today are rules for oxoanions. So oxoanions are the anions that contain oxygen. So if you take a look at the ones the oxygen containing ones, not hydroxide, so not every oxygen containing polyatomic ion is truly a oxoanion, but nitrate would be. So when we have an oxoanion, let's move this up a little bit. I want you to notice that the ATE ending means that it's going to be a polyatomic ion that contains oxygen. And we'll find out it's ATE or ITE. So if you see ATE, you know that it's going to have oxygen. And then the other part, since the other atom in this polyatomic ion is nitrogen, this would be called nitrate. This is chlorate. It has oxygen. Chlorate is going to be oxygen and chlorine. And permanganate. Now permanganate has oxygen and it has the manganese ion. So some of the things that we're to help you memorize, carbonate, sulfate. Sulfate is oxygen paired up with sulfur. Carbonate is carbon paired up with oxygen. And the same with chromate and dichromate. It's chromium paired up with oxygen. So if you see ATE, I want you to think of an oxoanion. It's a polyatomic ion where one of the atoms is oxygen. So that'll give you a hint on how it'll help with the memorizing process. Now, oxoanions, there's families of oxoanions. So if you know, for example, the name of one of the oxoanions, it can actually lead you to the name of the of its related oxoanion. So this, according to the list, let me clean this up a bit. So according to the list, SO4 is sulfate. Now the rule for the oxoanion families is the polyatomic ion that has one less oxygen than sulfate would be called sulfite. So SO4 minus 2 is sulfate. SO3 minus 2 would be sulfite. So you can see, knowing the names of these 14 polyatomic ions, you can actually extend beyond the ones that you memorized. So we've seen this one before. This is nitrate. It's right up here. So NO3 minus 1 is nitrate, ATE. The ATE is telling you that it's an oxoanion. So if we had a related oxoanion, not NO3, but one less oxygen, the naming convention would be that if NO3 minus 1 is nitrate, NO2 minus 1 would be nitrite. So we're looking for oxoanions. This is going to be a clue in their name. If they end in ITE or ATE, they're going to be a polyatomic ion that has oxygen. All right. Now, some of the oxoanions have families of 4. So in the chart, clean this up again. All right, in the chart, chlorate is like right here. So of the polyatomic ion series, we would know that this is chlorate. One less oxygen, we're going to still follow the same rule, would be chlorite. Now the other two, instead of adding or changing the suffix, we're going to add a prefix. And there are 2 prefixes we'll use. So PER is used for the anion that has 1 more oxygen. Like for example, here's chlorate. It has 3 oxygen. ClO4 would be perchlorate. It has 1 more oxygen. So we just use chlorate and we tack on a prefix. We don't change the ending at all. We're only taking chlorate, and it's still chlorate, but we're just going to tack on this PER to make it perchlorate. All right, so ClO minus. Okay, so if ClO2 minus is chlorite, we're going to tack on a different prefix. We'll call this hypochlorite. All right, so we'll tack on the hypo, means 1 less oxygen than chlorite. So these 2 are related and these 2 are related. So if we went through the manganese series, the manganese oxoanions, this is the one that we have to memorize. Permanganate, MnO4. So MnO4 is permanganate. It's the manganese atom partnered up with oxygen. MnO4 minus 1 is permanganate. So 1 less oxygen in permanganate, we just drop that prefix. This would just be known as manganate. And 1 less oxygen than manganate, MnO2 minus, would be manganite. And then 1 less oxygen than manganite, we'll tack on the prefix. This would be hypomanganite. So formulas that contain oxoanions, we have to be able to make predictions about the names. We should be able to make predictions. So let me see, where do I have room here? All right, so we can do like BrO3 minus. See, this is chlorate. ClO3 minus is called chlorate. This one's not even on the chart. We can assume that this would be bromate. So we can go through and do the entire oxoanion series. BrO2 minus would be bromite. BrO minus 1 would be hypobromite. And then we still have one more possibility. BrO4 minus 1 would be perbromite. So knowing the polyatomic ions, these 14, we extended it quite a bit. We can actually, if we know how the rules are for naming oxoanions, we can actually extend this 14 by applying the rules for oxoanions for the different families. Now there is one more possibility. We can combine hydrogen with some of the polyatomic ions. For example, if we take carbonate ion, which is CO3 minus 2, and add hydrogen to it, we end up with a new formula called new polyatomic ion called hydrogen carbonate. And I want you to notice on these, the charges didn't change. The charges stayed the same from whatever they were. But here we have a minus 2 and a plus 1 charge. So these would add up. So the carbonate minus 2 and adding a plus 1 to it. So the hydrogen carbonate would be minus 1. That's the way it would add up. Sulfate is SO4 minus 2. If we take sulfate and hydrogen and combine that, we'll end up with another polyatomic ion called hydrogen sulfate. Now sulfate is minus 2, hydrogen is plus 1, so the hydrogen sulfate ion would be a minus 1 charge. Phosphate is PO4 minus 3. So if we combined hydrogen with phosphate, we would have a new formula. This would be hydrogen phosphate, HPO4. Now, this is plus 1. Phosphate is minus 3, so that adds up to be a minus 2 charge. So that's going to be the key idea here. You're going to need to know your polyatomic ions. Put a star next to that. Go back and memorize the tables so that we can actually begin the next video by showing how we would actually name the different compounds.